This has been a question that has baffled oncology for decades. Arguments pro and con. The natural bent doctors make a big point that sugar feeds cancer. Cancer is a consummate sugar consumer. Oncologists just go poo poo. Really, we don't believe that. So, what's the truth? Does sugar feed cancer? Looking for research pieces that deal with that is very difficult. But a new piece came out of France on the 24th of March. I've been hanging on to this for a couple of months. That was a research piece looking at glucose levels in relationship to lung cancer therapy. Listen, cancers are not only made of tumor cells. In fact, as they grow, they develop an entire cellular ecosystem within and around themselves. If we understand the difference between a normal cell in our body and a cancer cell, its capability of producing enough energy for itself. Our normal cells, through the use of the Krebs cycle, produce energy to support themselves, ATP energy. It's one of the points we've been talking about in our 90-day weight loss plan. But cancer cells do it a different way. They lose that capacity and they become parasitic. They live off of us. This tumor microenvironment is made up of multiple cell types, including cells of the immune system, like T lymphocytes and neutrophils. That's new. That's new, folks. Listen up. I know this sounds confusing. The tumor microenvironment has predictably drawn a lot of interest from cancer researchers who are constantly searching for potential therapeutic targets. When it comes to the immune cells, most research focuses on T lymphocytes, T standing for thymus, the middle part of your chest, thymus-mediated lymphocytes. They become the primary target of cancer immunotherapy, a cancer therapy that turns the patient's own immune system against the tumor. But there's another type of immune cell in the tumor microenvironment whose importance in cancer development has been overlooked: neutrophils, the most prevalent type of white blood cells, which form a part of the body's immediate or innate immune response to microbes, things that invade our body. The question currently debated among scientists is whether neutrophils help or inhibit tumor growth. Do they get in the way? Because typically when you're looking at blood work, we're trying to increase these T lymphocytes and decrease the percentage of neutrophils. Now a team of researchers led by Etienne Milan at the EPFL School of Life Sciences has developed that the metabolism of neutrophils determines their tumor supportive behavior in lung cancer development. Studies published in the Journal of Cancer Research. What intrigued the scientists was that cell metabolism in cancer becomes deregulated. That's what I said. That's been known for some time. Being neutrophil specialists, they considered the possibility that when these cells reside within the tumor microenvironment, their metabolism may also change, and that could affect how they contribute to the cancer growth. Here's the important part. Focusing on glucose metabolism in a genetically engineered mouse model of lung adenocarcinoma, the scientists isolated tumor-associated neutrophils and compared them to neutrophils from healthy lungs. What they found was surprising. Tumor-associated neutrophils take up and metabolize glucose much more effectively than the neutrophils from healthy lungs. Almost to the extent of 3 to 4 times as rapidly. They also found that these tumor-associated neutrophils express a higher amount of a protein called GLUT1, which sits on the cell surface and enables increased glucose uptake and use. Can we metabolically starve a cancer cell? If we had a way to basically break down and extremely limit glucose intake into the body, To understand the importance of this during lung tumor development, they used a sophisticated symptoms to remove that GLUT1, that marker that came off during glucose metabolism. Using this approach, we identified that GLUT1 is essential to prolong neutrophil lifespan in tumors. In the absence of GLUT1, how do you do that? You lower glucose intake. They found these tumors started to die. Using X-ray microtomography to monitor adenocarcinoma, the researchers found that removing GLUT1 from these neutrophils led to lower tumor growth rate and an increased efficacy of radiotherapy, a common treatment for lung cancer. In other words, the ability of these tumor-associated neutrophils to metabolize glucose efficiently seems to bestow the tumor with the ability to resist treatment. At least we now know in lung cancer. Does sugar feed cancer? We now know how. We now know how. Been isolated in this research piece coming out of France. This is a short little YouTube, but the importance of it is dramatic. That if you know somebody that's just starting this battle with cancer, they need to talk to somebody who knows how to work their dietary intake during this time. They need to maintain their body weight. They need to maintain their muscle mass. They need to maintain their energy input, but they need to limit glucose. And there are specific ways to do that dietarily. Your life can depend on it. Lung cancer resistance. If you want to look up this article yourself, let's see here. It came in the Journal of Cancer Research, 2021, volume 2870. GLUT1 expression in tumor-associated neutrophils promotes lung cancer. Put it in English terms, excess glucose not handled properly by the body feeds cancer. And now we know how. The argument up to this point is, how can that glucose goes directly to feed the tumor growth? But what it did is built a wall of resistance for that tumor to propagate on its own so our own innate immune system cannot attack it. It's important, folks. It's important. If you want more information on this, give me a call at 678-228-8900, 678-228-8900. Our website is thenutritionshop.net. God bless you, folks. If you know somebody that's starting this battle for their life in cancer, tell them to give a call. See if we can at least assist during the course of whatever therapy they do. Have a great, healthy day, folks. Go listen to this again. It's important. God bless you. Take care.